So this is Algebra 2 with trig. We're working on 1B.3b. This is kind of a review of all of our standard form, vertex form, and intercept form of a quadratic. So we're going to look at what the equations are. So why don't you take a moment, pause the video, write down what you consider to be your standard form of an equation, your vertex form of an equation, and your intercept form of equation using all the variables. So looking at standard form, that's going to be ax squared plus bx plus c. Our vertex form was ax minus h squared plus k. And our intercept form was ax minus p x minus q. Those were our different forms of the equation. Now, each one of these forms of the equation talked about key values. What does each equation tell you specifically? Vertex form probably tells you about the vertex. Intercepts probably tell you about some sort of intercept. Standard form is kind of a tricky one, but there's an intercept in there also. So what are the key values? What do the variables stand for in each of those? Go ahead, pause it up, come back and check out your results. For standard form, we know that the C value that's going to be the Y-intercept. We know that the H and K of the vertex form that's going to be the vertex. And we know that P comma 0 and Q comma 0 are X-intercepts. So those are the key parts to those different types of equations. So when you're trying to find where an object's going to land, we would typically call landing would be on your X-intercept. So that's going to be very helpful. When you're talking about a high point, what's the maximum height? That's going to be very helpful in vertex form. And when you're talking about where is the object when time is 0, that would typically be your Y-intercept. That's your C value. All right, this is a little bit more generic, but how do we know about what the parabola opens? How do we know how the parabola opens? How do we know it opens up? How do we know when it opens down? Put in some notes for that, and then come on back and check us out. If A is greater than 0, then the parabola is going to open upwards. If A is less than 0, if it's negative, it's going to open downwards. And that's the same thing all the way across. If you have a positive A, you're going to open upwards, and a negative A, you're going to open downwards. How do we determine if we have a max or a min? It's kind of the same format. The notes are going to be extremely similar, but what determines if it's a max or a min? What's that about? So very similarly, if A is greater than 0, we know that the graph is going to open upwards. That's going to give us this low point. It's going to give us a minimum point. if A is greater, actually this is less than, this one's greater, A is greater than 0, A is less than 0, we're going to have a maximum. So it might be opposite of what you think about. If you think that A is positive, positive meaning big, yes, the graph goes big. It goes big forever. So you can never get to a high point. It goes up forever. So it's going to have a low point. There's a minimum value that can happen when A is positive. And that's the same for all three types. So the next one we're looking at here is our line of symmetry. What determines our line of symmetry? What's our equation? Each type of quadratic has a different formula. What are the formulas? Look in your notes, go off your memory, pause the video, come back and check out the results. So to find the line of symmetry in standard form, we're going to do negative b over 2a. That formula should look pretty familiar. Negative b over 2a. You take your b term, you do the opposite sign of it, and divide it by 2 times a. In vertex form, remember the vertex is your h comma k, so your line of symmetry is going to be whatever the x value is of the vertex, and we figure that out by x equals h. And then intercept form, it's going to be in between the x-intercepts. It's going to be halfway in between. It's the average. So x is going to be p plus q divided by 2. That's your line of symmetry in standard form. Well, that is actually intercept form. This one here is standard form, and the middle one is vertex form. What are we going to do now to find the vertex? We typically have to find the line of symmetry first. Then we find the vertex. So what's your process for that? In standard form, to find the vertex, we are going to plug x equals negative b over 2a in to the equation. So whatever you get for x, that value gets plugged into the equation. Of course, the vertex for vertex form is pretty simple. You just take the formula, you take your h term, which is always the opposite of what's inside the parentheses, and you take your k term, exactly the way it's written, right here. For intercept form, we're going to plug x equals p plus q divided by 2. We're going to plug that into the equation. Our next topic is to look at the y-intercept. What are we going to do for the y-intercept? How do we calculate that for each of the three forms? Pause the video, come back and see how you do. Put down your notes. Look it up if you need to. For standard form, we're looking for the y-intercept. In standard form, the c value That is the y-intercept. So it's in the equation. It's the value that doesn't have any x's on it. It's the constant number. For vertex form and intercept form, you need to plug 0 in for x. The y-intercept is the value where x is 0. So you want to find out what happens in the equation when x is 0. And that will give you your y-intercept. If you do that to standard form, if you plug 0 in, you'll ax squared, we look up here at the equation, ax squared, make that 0 squared, so we get 0, and b times 0, there you get 0, so you're left with c. That's why the c value is the y-intercept. All right, now we haven't really learned this part, but how do we find x-intercepts? What would it mean to be x-intercepts? So for us to find the x-intercepts in standard form, we're of course going to set y to 0 because that's your x-axis. And when you do that, you're going to need to factor. Typically, we factor. We can use quadratic formula. We can use completing the square. But we factor then use the 0 product property. So that's what we're going to do with standard form. This can be part of solving. We'll be doing that shortly. In vertex form, we set y equal to 0. Then solve for x. That's going to be something we do in the future. And then, of course, in intercept form, our p comma 0 and q comma 0 will be our x-intercepts. And the last thing we're talking about here is how many points should we put on a graph. And there's no just number one answer to this, but what do you think? What do I need to plot when I'm plotting these out? Give some thought to that and come back and check out. When we plot out our graphs, we can definitely, we've got to get a vertex. That's definitely one of the points. And we typically get a y-intercept. And we like to reflect. So we call that a reflection point. So that's at least 3. Sometimes we even do x-intercepts. Depending on what we know. We would definitely know that for the x-intercepts, the intercept form. Okay, so we're getting 3 to 5 points. And that's really, I could write it out again and again, but for the most part, that's all the same all the way through. You're going to find a vertex. You're going to find a point. Maybe it's the y-intercept. You're going to reflect it. and you could find another point. Maybe they're the intercepts, maybe they're just a third point, and reflect that. Good job.